Hello and welcome back. Today we're reacting to some more Kurzgesagt. Today we're going to check out the most dangerous stuff in the universe, strange stars explained. We watched the video on neutron stars, which was a great video. I learned a lot from it. And basically neutron stars are failed black holes. They're not quite dense enough to turn into a black hole, but they're the closest thing. I'm guessing by the name of the video, Strange Stars, we're going to be talking about strange matter, which was very briefly mentioned in that video as us not fully understanding it, because it's not something we can create here in a laboratory. It's not something that we can directly really observe close up. It's something that only exists in potentially the heart of neutron stars, is my understanding. So my guess is we're going to dive a little bit more into that. Let's check it out.
Neutron stars are the densest things that are not black holes.
Yep.
In their cores, we might find the most dangerous substance in existence. Strange matter. A bizarre thing so extreme that it bends the rules of the universe and could infect and destroy
Everything's just squished.
Or it could teach us about how the universe began. Maybe both.
If it could spread and everything, wouldn't it spread into the whole star?
To understand how extreme strange matter really is, we first need to get a few basics. What is a neutron star, and how does strange matter break the rules of the universe?
Technically, nothing breaks the rules of the universe, because if it's doing it, then that's in the rules of the universe. Subscribe for more philosophy tips.
Get all of this into one video will grossly oversimplify a few things, but will provide you with further reading.
They are very good at simplifying things down.
After a very massive star explodes in a supernova. When this happens, the star's core collapses under its own gravity.
Because you got to find that balance between giving too much information and making the information, the video, inaccessible to your target audience,
and turn into neutrons.
Or simplifying things so that way you can grasp a concept, but you might tell a few white lies here and there to get the point across.
They desperately push back against gravity, against the collapse. If gravity wins, they will become a black hole. If they win, they become a neutron star. This makes neutron stars like giant atomic nuclei the size of a city, but holding the mass of our sun.
That's so cool.
Here, things get weird.
Or strange.
Neutron stars is so extreme that the rules of nuclear physics change. And this could lead to a strange and extremely dangerous substance.
I wonder if one of the things that a theory of quantum gravity would fix would be this strange matter. Maybe the reason that we don't understand it is because we don't have a functional theory of quantum gravity that actually ties in and works with the theory of general relativity. Right? We don't have a theory of everything yet. We can't make quantum mechanics and general relativity work together. And a theory of quantum gravity is going to try to do that. And we just don't have that yet. We don't have a working theory. Once we have that figured out, it would have to incorporate some of these mysteries as to why strange matter is so strange and what happens under those extreme pressures and why.
But let's not get ahead of ourselves. We
Quarks!
first need to know the rules before we learn how they can be broken. Protons and neutrons.
Oh, they missed an opportunity there. They could have made the duck go quark.
Smaller particles
Quark,
called
quark.
quarks. Quarks really don't want to
God,
be
I'm so
alone.
weird.
They are what we call confined. You can try to separate them, but the harder you pull, the harder they try to pull themselves back together. If you use a lot of energy, they just use this energy to create new quarks.
Huh.
Quarks only exist together as the building blocks of other particles and have never been observed by themselves.
Okay.
They come in many types, but only two appear to make stable matter. The up and down quarks found in protons and neutrons.
Ah.
All other quarks seem to decay away quickly. But this may be different inside neutron stars. The forces operating in their cores...
I love how we named one of them the strange quark.
...similar to the universe shortly after the Big Bang. Neutron star cores are like fossils, which can let us peer back in time to the beginning of everything. So learning how quarks behave inside a neutron star is a way of understanding the very nature...
So the strange quarks were probably abundant, or strange matter, at the beginning of the universe. But since the strange quarks quickly dissolve...
all the particles cram shoulder to shoulder, dissolve and melt into a sort of bath of quarks. uncountable numbers of particles become one giant thing made purely from quarks. Quark matter. A star
Quark
made
matter.
from this is called a quark star, though from the outside it may not look any different than a regular neutron star.
How can you tell that that's
Now,
the
we
inside
can
of the
finally
star?
talk about the
There's
most
got to be a
dangerous substance.
cool way to tell that,
If
right?
the pressure inside a quark star is great enough, it may get stranger. Literally. In the cores of neutron stars,
It's hulking out.
may be converted into strange quarks.
Gotta be a Hulk
Strange
reference,
quarks
right?
have bizarre nuclear properties, and they are heavier, and for the lack of a better word, stronger. If they turn up, they could create strange matter. Strange matter might be the ideal state of matter. Perfectly dense, perfectly stable, indestructible. More stable than any other matter in the universe. So stable that it can exist outside neutron stars. If this is the case, we have a problem.
How could it exist outside the neutron stars? Because doesn't it need that immense pressure in order to exist in the first place, to overcome the outward pressure? Because like they were saying, the protons, neutrons, and the quarks and stuff, they don't want to be apart from each other. Or the quarks don't want to be apart, but protons, neutrons, they have a repulsive force, right? They don't want to be together. So you have an outward force that's being overcome by the immense just gravitational force of the star. So if you ease that, wouldn't it want to go back to a more normal state? Or once it's in this state of strange matter, would it just kind of want to stay there? It's taking energy to compress everything. And if you were to remove that compression energy from gravity, it would no longer be held in. Unless there's like a tipping point where some underlying force takes over and then it stays in that compressed state. I guess I really just don't know enough about this.
It might be infectious. Every piece of matter it touches might be so impressed by its stability that it would immediately turn it into strange matter too.
That would take energy though,
Protons and
wouldn't it?
neutrons would dissolve and become part of the quark bath, which frees energy and creates more strange matter.
Freeze energy.
The only way to get rid of it would be to throw it into a black hole. But then again, who cares? All of it is inside neutron stars.
Okay.
Except when neutron stars collide with other neutron stars, or black holes, they spew out tremendous amounts of their insides, some of which could include little droplets of strange matter called strangelets.
Strangelets.
Strangelets are
I love how they
as dense as
name
the core of a
things.
neutron star. They could be really small, maybe even subatomic.
Okay, but
Even the
if this is true, right? If it did spread and these little strangelets are getting strewn around the universe from neutron star collisions, wouldn't we see evidence of that? Because I know space is huge and space is empty, but it would hit something eventually. You'd think that we would see some evidence of this happening.
largest strangelets wouldn't be any bigger than a rocket. These strangelets would drift through the galaxy for millions or billions of years until they meet a star or planet by chance. If one were to strike Earth, it would immediately start converting it into strange matter.
That's a scary thought,
The more it
though.
converts, the more it would grow. Ultimately, all of the atoms making up Earth would be converted. Earth would become a hot clump of strange matter the size of an asteroid. If a strangelet strikes the sun, it would collapse into a strange star, eating through it like fire through a dry forest. This would not change the sun's mass much, but it would become way less bright, so Earth would freeze to death. And like a tiny virus, we'd have no way to see a strangelet coming. Worse still, some theories suggest strangelets are more than common, outnumbering all stars in the galaxy. These strangelets could have formed very early after the Big Bang, when it was as hot and dense as a neutron star core everywhere.
Okay.
They might be clumping around the gravity of galaxies as the universe expanded and evolved.
Kurzgesagt is very
Strangelets could
good.
even be so numerous.
They're very good at building up like an existential crisis of sorts, right? They're really good at piling on like the negative scenario, the impending doom. And then they kind of just get it really like down there. And then at the end, they kind of bring it back up with, you know, the ray of hope. And I'm guessing that's what's going to happen in this video, right? They're kind of building into that impending doom. And then at the end, it's going to be some ray of hope as to why this probably isn't going to happen. But to go back on my point earlier, I really think that if this was the case, we would see evidence of that. Because we would be able to see a star, a neutron star, that has mass less than it should, right? Like if a star was hit by one of these strangelets and ended up converting it into a strange star, that star wouldn't have the mass that it should have to be a naturally occurring neutron star.
And massive that they might actually be the dark matter we suspect holds galaxies together. But then again, maybe not.
But they're not dark though, right?
And the Earth and Sun and planets haven't been consumed in a wildfire of strangelets in the past few billion years, so the odds seem good that it won't happen anytime soon.
I have to say, I get the theory,
These strange objects,
but I'm not buying this one a little bit.
The birth of our universe and
I don't think it would spread.
It does now. When scientists first started playing with magnets and wires and thinking about electrons, they had no idea how technology would evolve in the next 100 years.
Yeah, that's true.
Scientists thinking about the cause of neutron stars and strange matter today may be setting up humans for a future beyond our wildest imaginations. Or maybe not. Time will tell.
Yeah.
So while you're waiting to see if the universe gets destroyed, you might still want to find out more about it.
I do have to say, this is the first Kurzgesagt video where I personally don't agree with the outcome. I don't think that I'm following or buying the strange matter spreading, that just by touching other matter it converts it into strange matter. To me, that doesn't really make a lot of sense because it seems like that interaction would require energy. It might release energy, but a lot of things that release energy require energy to get started. And a lot of them, you got to put more energy into it than you get out of it. So maybe I just don't know enough about this particular topic. Do you agree with me on that, or do you have a different take on it? I'd be very interested to hear. Anyway, thank you so much for watching. I really appreciate it. If you like this, please hit the like button. If you want to see more, hit that subscribe button. And I hope that you have a wonderful day.